Hey, Chem 112. It's Virginia here to go through practice exam 4S. Let's go ahead and get into it. The first question says that standard reduction potentials of all substances are reported compared to the reduction of water. So this is going to be false because instead everything is compared to the reduction of hydrogen. And if you didn't remember that, if you look at the data sheet, the value for hydrogen is 0 because everything else is compared to that. Okay, for number 2, we have thermite. And this is the reaction we always do in the flower pot with that magnesium wick sticking out. They want us to figure out what the oxidizing agent is in the reaction. So oxidizing agent is what gets reduced. And this is going to be then what gains electrons. And we will look for a decrease in the oxidation number. So we'll have to go through and assign oxidation numbers for all of the molecules and atoms in the molecules. And we can start with this iron oxide. So we don't know anything about iron, but we do know oxygen prefers an oxidation state of -2. There's 3 oxygens, so overall they'll contribute -6. So the iron, to make the molecule overall neutral, will have to contribute +6. There's 2 of them, so each one is going to be +3. And it's those top numbers for the individual atoms that we'll use to do our comparison. The aluminum's easy, it's just going to be 0. Same with the iron. And then we'll have -2 for the oxygen here, overall -6. We'll have +6 for the alumina, overall, or individually +3. So we want to look for the one that has a decrease in the oxidation number, and so that is going to be the iron. And so when we're looking for the oxidizing agent, we want to pick the reagent that has the iron in it, which is going to be the iron oxide. Okay, for number 3, I think there is an error in the question, but it asks us which of the following is, and so I'm going to address it as if the not is not there. So which of the following is always true for spontaneous reaction? And so we know that that's something that's going to go forward toward products. We know that that means a negative delta G and a positive potential. So when we go forward toward products, that means our Q must be less than K, and we would have too many reactants. So we have to go forward to make more products. So if we look at the options, A is going to be true. That will be the case when we have a spontaneous reaction. And the other 2 would correspond to a non-spontaneous reaction. Okay, for number 4, they want us to pick out which of the following reactions is a redox reaction. And so we want to look for the reaction where there's a change in the oxidation numbers, because that will correspond to some transfer of electrons. So we'll have to assign for all of the atoms in all of these molecules. So in A, we'll start with the ammonia. We'll say each hydrogen is +1, overall +3. So the nitrogen must be -3. In water, say each hydrogen's +1, overall +2. So the oxygen is -2. And then this molecule looks scary, but we can take it one atom at a time. So say the hydrogens are +1. So we'll have +4 from there and +1 from here. And we'll give our oxygen the -2, -2. So right now we have overall +3. So the nitrogen is going to need to be -3, which is the same as it was before. So nothing changed here. So this is not going to be the answer. It's not a redox reaction. And we know what kind of reaction that is. That's a base hydrolysis. Okay. So we'll do the same thing for B. Hydrogen +1, +1, oxygen -2, overall -6. So the nitrogen must be +5, +5. What I'm going to do is I'm going to call just this overall hydroxide as -1. So this whole group -2 overall. So the calcium is going to have to be +2. And then here we'll have our nitrate group, which is overall -1. So we'll have -2 for both of those, and the calcium will be +2. And then we'll have water, which we know is +1 and -2. So we can see that nothing here changed. And this makes sense because this is just an acid-base neutralization reaction. Okay, and so then for C, we'll have -2, -6 overall, +6. Water we know is +1, -2. And then here I'll again call our hydroxide overall -1. We have 2 of them, so -2. Then we have the oxygens here, so I'll give those -2. Both of those will contribute a total of -4. So our sulfur must be +6 to make the molecule neutral. We can see there nothing changed again, so that is not a redox reaction either. Okay, here we have chlorine on its own, so it's just going to be 0. Potassium is an alkali metal, so we'll assign that first. We get +1, so the iodine is going to have to be -1. Here the iodine is going to be 0. Potassium again is going to be +1, so the chlorine is going to have to be -1. And so here we see there is a change in oxidation numbers, so that's going to be our redox reaction. And then if we look at this reaction, we can see we have some things coming together to form a transition metal ion complex. So this would be like our KF reaction. That's not going to be a redox reaction. Which brings us to the next question, number 5, which says, which of the following reactions is a formation reaction? And so we know that this is when we have some kind of metal ion or metal salt. So I'll give it some charge, plus some Lewis base that can act as the ligand, coming together to form some complex, which we usually see denoted with the black brackets. And so if we look at A, this is some sort of base hydrolysis. The second one is acid-base neutralization. The third, I think, is also base hydrolysis of some sort. And for the fourth one, it's just, that is our redox reaction. And then here, as we said before, this is our formation. We know we have our transition metal. Ammonia has a lone pair, so it can act as our Lewis base or our ligand. And then we make the complex. So this would be, have some KF.